Alright, as with all the other tests, chapters 9 and 10 test as well, just remember you can go over the problems as many times as you need. If I'm going too fast, you should be able to slow it down somehow or just pause it at certain points in order to figure out what you need to, alright? But we're going to go in order from 1 till the end. So if there's a problem you're looking for specifically, just go to that problem, fast forward this video to that problem, and then just go over that one as many times as you need. But make sure you understand the concepts. Like I recommend with all the other tests, do the problems as many times as you need to. Download the test, print it, do it as many times as you need until you feel very comfortable with all of the material, and that should allow you to do very well on the test. So if you do the practice test, and you can download the key as well, the answer key from the Canvas website. If you look at the key and you see that you've gotten something wrong, then you'll want to go over the problem, show all your work as it says there, and hopefully you can go back through, just go through your work and see where you made the mistake. Alright, check the homework as well if you need to see how you're doing the problems on the homework. If you're showing work there shouldn't be any problem as to the technique that you're using. So good luck with that. Study hard, and I hope this is helpful for you as you prepare for the test. Alright, on number 1 we have this f of x equals x plus 3 and g of x equals 3x minus 1. And what it tells us to do there is that we have f plus g of x. So all that means is that we're going to take the two functions and add them together. So we have essentially what would be f of x plus g of x. And f of x is x plus 3. And we'll add that to g of x, which is 3x minus 1. Then all we need to do is simplify this, alright? So combining like terms, let's combine the x's here, that's a 1x, plus that 3x would be 4x. Then we have a 3 minus 1, which would be a positive 2. That's it right there, that's our answer. Alright, on number 2, we have f minus g of x. All that means is that we're going to take f of x and subtract g of x. So we're just going to write this function exactly how it is, this x plus 3. The problem is that this is minus the entire function, so you may want to put g of x in parentheses like this. And what that means is that when we put the 3x minus 1 in, it's the negative or the opposite value of both of those, okay? So we end up writing this x plus 3, and that's a minus 3x, and the opposite of minus is plus 1. So don't forget to do that, because that's a common mistake that a lot of people make, is to they'll change the sign of the 3x here, but they won't change the minus to a plus, which is absolutely necessary if we want to get the right answer for this. So now in this case we're just going to combine like terms from here. So x, that's a 1x minus 3x, that's a negative 2x, and then a 3 plus 1 is a positive 4, and you can see the difference there. If you left that as a minus 1, you'd have a plus 2. So please don't forget to change the sign of that minus. Now let's take a look at 3. 3 is the same idea, except for now it's just multiplication. So f times g of x, so we're just going to take f of x, times it by g of x. And f of x is that x plus 3. And we'll multiply this using parentheses, 3x minus 1. And from here, you're just going to use the regular FOIL technique that you're used to using. We got x times 3x, which would give us a 3x squared. Then we have x times a negative 1, that's a negative 1x. Then we'll do 3 times 3x, which is a positive 9x. And then 3 times negative 1 is a minus 3 there. From here, all it is about combining these like terms. Negative 1x plus 9x, that's going to be a positive 8x. But the 3x squared, there was no other like terms to combine with it. And the negative 3, there were also no other like terms. So this is how our answer looks. Then finally we have 4, which is f divided by g of x. So we have f of x, and we'll divide this by g of x, which is equal to f of x is x plus 3. G of x is 3x minus 1. And we can tell right away that x cannot be positive 1/3. And we could look at this, we could stare at it all day, but the fact is that there is no factors that we can cancel out. We can't even factor out any common terms because these are all essentially prime here. So this is it. As it turns out, this is the answer there. And of course, x does not equal 1/3 and has to be part of the answer. So number 5, that was a misprint on the paper there for some of you. So you can see that is f of g of x. So we'll go ahead and write this as it should be. Would be f of, well, that would, let me just write it originally. It's f of x equals the square root of x, right? But the problem is that instead of x, we're going to replace it with g of x. I'll make that a different color here. G of x. So wherever we see the x, we're going to replace it with g of x. I can put bigger parentheses there. So what we end up with is f of g of x, which actually is, as you can see there at the bottom, it's actually x plus 1. And so writing this as it should be, perhaps using the book notation, f of g of x equals, by the way, this, we can't simplify this anymore, so we'll just leave it as it is, x plus 1. That's the answer for number 5. Alright, on 6, we'll do the same thing, but now instead of it's f of g of x, we now g of x, which is what we'll start with, which is x plus 1. But we're going to replace the x with an f of x. And so we'll also replace the x with f of x, and we're just going to add the 1. Well, f of x, you can see, and I'll just write this one right now, g of f of x equals f of x is actually the square root of x, then we'll add 1. And that's it. Again, this one can't be simplified any further, and that's it. Alright, on number 7, we're going to go ahead and we can see that's f of negative 2. So again, I'm just going to use the same technique. I'll just show this, not that everyone needs to see this part, but the original function here is x cubed plus 2. And what I'll go ahead and do is go ahead and replace this x with that negative 2, which is what we want. So that would be a negative 2 here. And this would equal, negative 2 cubed is a negative 8. So it's a negative 2 times negative 2 times negative 2. And then we'll add the 2 there. So this ends up just being a negative 6. So f of negative 2 equals negative 6. This would be the correct notation. Looking at number 8, the problem is we need to figure out what the inverse function is of x there. So we see that we have f of x equals x cubed plus 2. Well, what I really want to do is replace f of x now with y. Okay, so this is the original function or equation, And in order to find the inverse function, all we're going to do is switch the x and y, not the cubed, just where they are. So what this ends up being is x equals y cubed plus 2, and from here we need to solve for x, for y. So from this point, in order to solve for y, you're just going to use the same techniques you've been using. So we'd have an x minus 2 equals y cubed. You can use the principles of equality or switching state game, whatever you need to do. And from this point, we'd have to cube root both sides, and would end up finding that that's the cube root. Y is the cube root of x minus 2. But we're not finished with this because, again, this is the inverse function, so we'll write it in the correct notation like this. Okay, but what we do know is that we want this to be f of negative 6. So rewriting this, we have inverse function of x, but x now is negative 6, equals the cube root, and again, instead of x, we're going to use a negative 6 minus 2. Well, this gives us the cube root of negative 8, which ends up being a negative 2. So the correct notation for this would be inverse function of negative 6 equals negative 2. Alright, for number 9, we want to figure out if this is a one-to-one function. So in order to do that, we're just going to run a horizontal line test. Okay, hope you remember that from class. And all we want from this is to make sure that the line only intersects the horizontal line once. So if I move this line down, if I see any place where it intersects more than once, now it's starting to kind of flatten out there, but it continues to decrease rapidly right here, and then it kind of narrows out. But from this part of the graph, it doesn't look like it will intersect that horizontal line more than once. So yes, this one is 1 to 1. Alright, on number 10, we're going to do the same thing. Let's go and take our line and move it down, and bam, right there. We can see, it looks like it's intersecting in 4 places, which it will continue to do. And if that pattern did continue, it even intersect in more places than just the 4 that we're looking at in this position, up to the 5 here, and so forth. Okay, so this one is not 1 to 1. Alright, on number 11, the first thing we need to do is find the inverse of this function. Then we'll graph both of them. You could graph this function right away if you wanted to, but what I want to do here is find the inverse first. Okay? So again, I'm going to replace the x with the y and the y with the x. So I end up with x equals y plus 2 cubed. Alright, and what I can do here is cube root both of these. Cube root, and that ends up canceling those cubes out and cube roots. So I end up with the cube root of x equals y plus 2. Because again, after we replace the x and y's with each other, and all we're doing is solving for y, so I'm going to subtract 2 in this case. And that would give me my function, inverse function of x equals the square, or the cube root rather, of x minus the 2. Okay, now remember that negative, or that minus 2, does not fall under that cube root. Alright, so from here, let's go ahead and look. If we take, and we can just create tables in order to solve these, alright? So for example, I'll have an x and then an f of x. This will be my original function, x plus 2 cubed. then we'll just find some different values for this, okay? Now, since it's cubed, we can go ahead and find some negatives. It's not going to matter. Let's go ahead and use some values, -2, -1, 0, 1, and 2. So -2, when x is -2, you'd get a 0. When x is -1, you would get 1. When x is 0, you'd get 8. If it's 1, you're going to get bigger numbers. So actually I'm going to change this to a -4, and I'll change this 2 into a -5. See if that helps me out, okay? So if x is -4, then I get a -8. And if x is -5, so -5, well, I guess I better change that one as well. I apologize. Let's go ahead and change it to a 3. -3 plus 2 is a -1, cubed is a -1. So this gives us some points to work with. So I am going to graph this original function in red. So here we go. X is -2. Give us some big points here. Right there. -1 and 1 would be right here. 0 and 8 is up there. Alright. Now we got -3, -1, -4, -8 right here. And that's it. Okay. So graphing this line, we should get something like this. Now what I'll do is I will graph the next function, the inverse function. So I have x and the inverse function of x, and I'll find some values for this one as well. Now what I want is some perfect cubes to work with in order to make these numbers work out much better. So for example, I may use x is -8. I may use x is -1, 0, 1, and a +8, and see what these give me. So -8, the cube root of -8 would be -2, but that's an equals there. So I'd have -2 minus 2 is a -4. If I use -1 in for x, then I've got cube root of -1 is still -1 minus 2 is -3. If I put 0 in for x, then I get 0 minus 2 is a -2. Now if I use positives, I'll have 1 minus 2, which is -1. And if I use 8, then I would get 2 minus 2 is 0. Alright, so let's see what this looks like on the graph. Okay, so when x is -8, f of inverse of f of x is a -4 right here. When I have x is -1, then I get a -3. When 0, we get this -2. When I get 1, I get -1, and when x is 8, I get 0. Alright, so let's go and look at the graph of this. Alright, so hopefully your graph looks something like this. Of course, this is based on the table that we made, and you could see, hopefully, that essentially that line has just been reflected over the y equals x line. So that's what it looks like. That's the graph. Alright, so for number 12, we are just going to graph this exponential function, and it won't matter what we use here. We can just try some different values, okay? We can try some negative values. It's not going to matter. We'll try a negative value up to a certain point because otherwise it's going to go off the graph. So this is going to be equal to y or f of x. That's not going to matter either. We can make it a function. Sure. All right. So I'm going to have my x's and my f of x's. Well, for x's, we will use -2, -1. Let's see. Let's use 0, 1, 2, and 3. See where this gets us. So if x is negative 2, then I'd have a negative 2 plus 2, which is 0. 3 to the power of 0 is 1. If I use x as negative 1, then I get a negative 1 plus 2, which is 1. 3 to the power of 1 is 3. 3 to the power of 2 is 9. So I'm kind of skipping a couple here. And then we would have a 27. So that's going to take us off the chart there already, a 1. So let's try some different values for these. Let's try some opposite parts, negative 3 and maybe some negative 4. Well, if x is negative 3, then I would have a 1/3, which may be a little difficult to graph. And then I'd get a 1/9 here. It's not a big deal. It's just going to be very close to 0. But understand that we can't get this line to cross the x-axis. So knowing this, let's go ahead and look at what our graph may look like. So at negative 2, I get a 1 right here. At negative 1, I get 3. At 0, I get 9, and then it's just going off the charts in that direction. If I have negative 3, I get negative 1/3. Negative 4 is 1/9, which probably should even be closer to the line than what I've graphed there. Or there. There we go. Something like this. Alright, so finishing this graph, again, it's going to get closer to 0, but it never will touch that x-axis, where y equals 0. Alright, and this is the graph that I came up with. Hopefully yours looks a little bit the same, but that would be about it. And again, the reason this can't go into the negatives down into this area is because it's a power of 3. It's not going to make 3 negative if that power is negative. All that means is if the exponent is negative, we're just going to take the reciprocal of whatever we have. All right, the first thing we need to realize on number 13 is looking at this, it's a lot easier than you may think, because 27 is actually 3 cubed. Now since that's a fraction, 1 over 3 cubed, we could rewrite this by taking the reciprocal of that 3 cubed. But if we do that, we have to make the exponent negative. What this allows us to do is rewrite this without the base 3's. So we end up with 2x equals negative 3, and just solving for x by dividing by 2, we end up with an x equals negative 3/2. That's it. That's all there is to this problem. And again, the main thing was just knowing that 27 equals 3 cubed. So with that in mind, it may be a good idea for you to just have some of the, probably the first 15 cubes and squares memorized. You can put that into a calculator, so it may not be that big of a problem for you, but it may save you some time if you have that memorized. Alright, 14 is going to work the same way, but it's going to be important for us to realize that 25 is a perfect square of 5, and 125 is a perfect cube of 5. So rewriting this, we would have 5 squared x minus 2 equals, that would be 5 cubed to the power of x. Now what this allows us to do, and some of you may remember this from the rules of exponents, is to just kind of break this down. We'd have 5, and this would end up being 2 times x minus 2, and this right side of the equation would have 3 times the x. So we end up with 5 to the power of 2x minus 4, and then 5 to the power of 3x, which again allows us to rewrite this as one single equation without the bases. 2x minus 4 equals 3x. Solving for the unknown, we would subtract the 2x from both sides, And we'll get negative 4 equals a 1x. And that's it right there. Alright, so in 15 we're going to use this formula, a equals p times quantity 1 plus r over n to the power of n times t. And the nice thing about this is that it tells us all the information we need in order to solve this problem. So what we want to figure out is A, the amount of the account if $2,000 is invested. That's our principal. Our principal here is $2,000 for 7 years, so that's our time and our rate R is a 5% interest, and N is the number of times compounded each year. Since it's quarterly, we're gonna compound this 4 times every year. So solving this, A equals P, which is 2,000 times 1 plus the rate, which is 0.05, divided by N, the number of times compounded every year, divided by the 4. And this is going to be raised to the power of 4 times the time, which is going to be over 7 years. Well, you can plug all this into a calculator directly. We can simplify it for you, but eventually I'm going to have to use a calculator as well. 2,000 times 1 plus 0.05 divided by 4. That would give us a 0.0125. And this is going to be raised 4 times 7. This is a power of 28. So simplifying even further, we get the amount equals 2,000 times 1.0125 to the power of 28. So A equals 2,000 times, I don't know what that is, to the power of 28 is going to be 1.41599, and then just multiplying that by 2,000 gives us the amount is $2,831.98. Alright, number 16, we want to write this in log notation. And hopefully you remember this from class, but if we have b to the power of y equals x, we can find the log. That would be y equals log sub b of x there, okay? So looking at this, we have 5 to the power of pi equals y, and so putting this into a log notation, we end up with, looks like we've got pi equals log, because our b is 5, so we got a 5, and the x from that is the y. So don't let that confuse you, because we use the y here. It really was the value of x, so we'll replace that x with that value of y. And also the y was pi here, so. But that's it. So on this one, we're going to write this in a log, this log notation, and turn it into an exponential notation. Alright, on 17 here, so we're going to go back to that, sorry about that, the log sub b of x equals y. This will give us x equals b of y, b to the power of y. And acknowledging here in this problem that we can rewrite it actually. We have the log sub 7, and I'm going to write this as 7 to the power of 1/3 equals 1/3. So this tells us that b is 7, y is 1/3, and x is 7 to the power of 1/3. So this allows us to rewrite this using this format over here, this exponential notation, and we would end up with, so it gives us, not the log, I apologize, the x is 7 to the 1/3, which would equal b is 7 and y was 1/3. That's true. So this is our answer. You may write that in a radical form, cube root of 7, that's fine. Alright, to solve for x on number 18, what we're going to have to do is use the property, I think it's the product property, right, with where we're going to take the log sub b of x plus the log sub b of y equals the log sub b of x times y. We can put that in parentheses if we want. And that's kind of what this is here. Because what we can do, since we have the log sub 6, we can take x times x plus 1 in this case. And this is going to equal 1 still. Simplifying, we get log sub 6 of x squared plus x equals 1. So all I did was distribute that x in there. So, alright, then using the properties of log, so again I'm going back to this log sub b of x equals y. That gives us x equals b to the power of y. So this would give us x squared plus x equals 6 to the power of 1. Solving for x, we would subtract 6 from both sides. So we have x squared plus x minus 6 equals 0. This is just a polynomial where we need to factor out a couple expressions there. So we get x plus 3 and x minus 2. So from this we see that x equals a negative 3 and a positive 2. Now what we need to do is just double check this answer in the original equation. So we're going to go back to the original and we'll go ahead and just replace these values here. So the values of x with those that we just found. Alright, so let's take a look. I'll take the log sub 6 of negative 3 plus log sub 6 of a negative 3 plus 1. This should equal 1. So the problem at this point is that we have this log sub 6 of a negative value, and we can't have negative values in the log. So as it turns out, the negative 3 right away is not going to work here. So this is not a problem. It just means that that negative 3 is not part of the answer. So now what we need to do is look at the 2. So log sub 6 of 2 plus log sub 6 of 2 plus 1, does this equal 1? Well, it looks like we're going to get this all right. This is going to change from log sub 6 of 2 times 3 should equal 1. So log sub 6 of 6 equals 1, and that's true. This is going to give us 6 equals 6 to the power of 1, which is a true statement. So in the end, x is just equal to a positive 2. Alright, to start off 19, what we can do is replace f of x with y. It's not going to matter there. With equals the log of sub 1/2 of x. And from here, all we're going to be looking to do is write this in exponential form, which would give us 1/2 to the power of y equals the x. Well, now that we have this information, what we're going to do is make a table again, and we're going to find some values that we can use in the graph that would be helpful. So we have our x and y. Alright, but again, since this is the power of y, what we really want to do, and that's equal to x, what we want to do here is find values of y. So we're just going to choose whatever values we want on this. I'm going to start with, let's say, a -3, and I'll just go down from there. Alright. And hopefully this will show us how this graph is going to look. Alright. So if y is -3, then I'd have 1/2 to the power of -3. That's going to reciprocate that fraction, and we'll just have 2 to the power of 3, which is 8. Same with y is -2. We're going to reciprocate it and take 2 to the power of 2, which is 4. 1 as well. Anything to the power of 0 is 1. But if we make y a positive 1, then it's just going to stay a 1/2. So let's go and take a look at what this graph, about what it should look like. Alright. So judging, this graph is a little small, but we can work with it. So if x is 8, then y was a -3, right? So we have a point there. When x is 4, we have y is -2. When x is 2, y is -1. When x is 1, y is 0. And when x is 1/2, y is 1. Now, we'll never have a negative value from this because the base is positive. So the x value will never be negative, meaning that this curved line will never cross the y-axis. So let's take a look at what this should look like, okay? And it's going to go up as the x value gets, as the y value increases, the x value will have to decrease. And but it won't go past 0. So let's take a look at that. Alright, so this is what I have. You can, this line isn't so curved up here, but it's going to get closer and closer to x equals 0, the y-axis. And also this number is going to start to level out here in this direction also, okay? Alright, for number 20, we're going to need these two properties of logs. We got the quotient and product rules. And that's what we're going to do. Starting from the left, let's look first at log sub 11 8 plus log sub 11 of 3. And what that would give us is, using the product rule, we would end up with log sub 11 of 8 times 3, which is log sub 11 of 24, right? Well, now what we have is log sub 11 of 24 minus log sub 11 of 2. And this is going to allow us to divide those, right? So we have log sub 11 of 24 over 2, which would then give us log sub 11 of 12, and that's it. Alright, just so you remember the power property, there it is. Now we can see that the x, which in this case is 4, doesn't really have a power, but it's a radical. That's not a problem for us because what we have is log sub 7 of, it'd be 4 to the power of 1/3. So since that's the case, we're going to essentially multiply the log by that power of 4, which is 1/3. So rewriting this, we get a 1/3 log sub 7 of 4. That's actually it. That's all we wanted right there. Alright, number 22, we're going to use properties of logarithms to write this expression as either the sum or different of multiples of logarithms. Alright, so since this is division, we can right away just look at this, and we would use the quotient rule here. We got log sub 2 of the numerator, 2x minus 1 to the power of 5, and this is going to be subtracting log sub 2 of x. Alright, the last thing we want to do is just get rid of that power, so we'll just use the power rule, and we'll go ahead and remove that 5. We'll place it in front of that log sub 2 there, so we have log sub 2 of 2x minus 1 minus log sub 2 of x. Alright, for 23, what we have here, some of you know that we're going to start actually with this part here when we're given these two. And what's important to realize is that this log sub b is 28, which can be divided into 7 times 4. So using the quotient property, we're going to go ahead and split this up. We're going to have log sub b of 7 plus log sub b of 4, which we know those values. The log sub b of 7 is 1.21 plus the log sub b of 4 is 0.87, which when we add these two together, you get 2.08. And that's the answer. Alright, 24, we're going to solve for x, and we'll have an exact and an approximate solution. So, I went ahead and wrote this up at the top for you. But some of you may remember that the natural log is the log sub e. So, what we can do is rewrite this as 2x plus 5 equals e to the power of 3.4. From here we're just solving for x, so we'll subtract 5 from both sides. And that leaves us with a 2x equals e to the power of 3.4 minus 5. And then we'll just divide both sides by 2. And that's what x is right there. I'll just get rid of this stuff here. And we have an x equals this. Now you could put this into a calculator, and if you did, you'd find the approximation 12.4821. I don't know that by heart, so I highly recommend using a calculator. And this one's done. Alright, so for 25, we're going to use this formula. And we know that from this, we're going to, it looks like our principal investment is $1,200. The rate is at 8%. And we're going to do this for 3 years. So again, this is just a matter of using a calculator because the amount accrued, we're going to use P is 1,200. That's our principal investment. This is multiplied by e to the power of our rate, which is 8. And we'll multiply that by the time, which is 3 years. So just working this problem out, we still have that 1200, but this is going to be e to the power of 0.24, and multiplying these out, again, you just use a calculator, you'll get 15.25 and 50 cents, and this is all in dollars. There you go. Alright, for 26, we'll solve for x and give an exact and approximate solution to 4 decimal places. Alright, well, what we need is for 2 to the power of x minus 3 to equal 5. Alright, on 26, let's go and rewrite this equation. We have 2 to the power of x minus 3 equals 5. And what we're going to do is use that property of log where we're going to turn it into, we're going to take the exponent and turn it into a log. So log sub b of x equals y actually gives us b to the power of y equals x. Well, if this is the case, then we're going to just essentially reverse it and go this direction. So what we end up with is a log sub 2 of 5 is going to equal that x minus 3. Now what I can do with this log sub 2 of 5 is I can split it up. I can have log of 5 over log of 2, and that's going to equal this x minus 3. But we need to get rid of that 3, so we're going to add 3 to both sides, and that's what it ends up being. Log of 5 over log of 2. Yeah, just remember that's a change of base property right there, that we were able to take it from this format into this format here. And that's the answer. And yes, I apologize. The approximation for that 26 is 5.3219. Alright, you can put that into a calculator, that log 5 over log 2 plus 3. Alright, on number 27, we're just going to solve for x once again. So this comes out, we need to make this log, essentially this part of the equation, into one, not this part, but into one log. So we're going to have log sub 4 of 10x equals that 2. Well, this allows us once again to use that property. So this is going to be 4 to the power of 2 equals 10x. 4 squared is 16 equals 10x, and we'll just divide both sides by 10, and that gives us x equals 16/10, but I'm going to simplify that. Dividing both by 2 gives me 8/5. So we're going to go ahead and find the center and radius of this graph, and in order to do that we need to rearrange this. So what we'll have is x squared minus 2x. I'm going to give myself some space because we're going to have to complete the square for both the x and the y. And so I'll add my y squared plus 6y equals the 6. Okay. Now completing the squares just for the x's, I would need to add a 1, and I would get that by taking a negative 2 divided by 2. I'm going to square that. That's going to equal 1. Same thing with the y's. I've got that b value, the 6. I'm going to take that divided by 2 and square that, which means I'll have to add 9 there. So from this, we can factor this, because it's a perfect square, x minus 1 squared, and then we'll add this to the y's as well. That's a y plus 3 squared. But we also need to add the 1 and the 9 to the 6, which would have given us 16. Hopefully you can see that. Let me make it a little bit thicker there. That's 16. Well, what this tells us is, well, this is now in the form of the circle, which some of you may remember. You'd have x minus h squared plus y minus k squared. This is going to equal our radius squared. So h in this case is 1. By the way, this is the center. The center is at hk. Our h is 1 and our k is a negative 3. So that's our center. Let's go and graph that right now. I'll graph it in red. 1, negative 3 should be right about there. Okay? And then after that, we have the radius, which is radius squared is 16. So we know the radius then is 4. Well, this allows us to graph this with a radius of 4, meaning that the circle will go through the points 4 away from that center. So 1, 2, 3, 4 should go through here. 1, 2, 3, 4 here as well. 1, 2, 3, 4 there. And 1, 2, 3, 4 right here. Okay, so hope you can see those purple dots. Now I'm just going to go ahead and graph this. Alright, and there we go. That's our circle. That looks pretty good. And we'll just go ahead and keep it like that. This formula, we can go ahead and figure out what our h and k are, remembering that the center is at h and k. So since our center h is 0 and k is a negative 2, we can go ahead and replace those values in the equation. H is 0 squared plus y minus the k, which is a negative 2, so that'll end up being a plus 2 there, equals the radius, which is the square root of 6, and we'll go ahead and square that. Alright, so simplifying this, we'd go ahead and get just an x squared, and that would be plus, it's the same thing, y plus 2 squared. And the square root of 6 squared is 6. And that right there is our final answer. And finally, I hope you have found this video to be helpful. Make sure that you study these problems as many times as you need to in order to really understand the material. Again, try to do it without any help from the video. Check your answers, come back to the video, check your work, and then try it again all by yourself. And of course, you're always welcome to look up questions in the book that we didn't do, because there's quite a few of those, and if you do those, and then check your answers in the back of the book, so you want to do the odd problems, check your answers, and then go over those a couple times if you have to, but it is a lot of work. But it's well worth it, so I hope you found this helpful. Good luck as you study for the test, and when you take the test, good luck on that as well.